Vinyl chloride is an organochloride with the formula C2H3Cl that is also called vinyl chloride monomer, VCM, or chloroethene. This colorless compound is an important industrial chemical chiefly used to produce the polymer polyvinyl chloride, PVC. About 13 billion kilograms are produced annually. VCM is among the top 20 largest petrochemicals, petroleum-derived chemicals, in world production. The United States currently remains the largest VCM manufacturing region because of its low production cost position in chlorine and ethylene raw materials. China is also a large manufacturer and one of the largest consumers of VCM. Vinyl chloride is a gas with a sweet odor. It is highly toxic, flammable, and carcinogenic. It can be formed in the environment when soil organisms break down chlorinated solvents such as trichloroethane and trichloroethylene. Vinyl chloride that is released by industries or formed by the breakdown of other chlorinated chemicals can enter the air and water supplies. Vinyl chloride is a common contaminant found near landfills. In the past, VCM has been used as a refrigerant. The U.S. Department of Health and Human Services, DHHS, classifies vinyl chloride as a Group 1 human carcinogen. Vinyl chloride may cause adverse health effects following exposure via inhalation or dermal contact. Most exposures occur in the industrial workplace. Acute exposure to high levels of vinyl chloride in air has resulted in central nervous system (CSN) effects in humans such as dizziness, drowsiness, and headaches in humans. Chronic exposure to vinyl chloride through inhalation and oral exposure in humans has resulted in liver damage. Vinyl chloride exposure has been shown to increase the risk of a rare form of liver cancer, angiosarcoma of the liver, in humans. Vinyl chloride is a highly regulated compound under OSHA, the Clean Air Act, and the Clean Water Act. The occupational safety and health standard for vinyl chloride as a toxic and hazardous substance is found in 29 CFR 1910.1017. This standard defines the role of the employer and employee to control vinyl chloride exposure in the workplace. The National Emission Standard for Hazardous Air Pollutants, NESHAP, are emission standards set by the EPA that were not addressed under the existing National Ambient Air Quality Standards, NAQS. The NESHAP standards are authorized by Section 112 of the 1970 Clean Air Act, and the regulations are published in 40 CFR Part 61. Vinyl chloride was one of the initial 7 compounds targeted under the Part 61 NESHAP standards, 1976, Subpart F, along with asbestos, 1971, beryllium, 1971, inorganic arsenic, 1980, mercury, 1971, radionuclides, 1979, and benzene, 1984. The initial vinyl chloride NESHAPs set precedents on control levels and forced new levels of technology. However, the issues surrounding vinyl chloride have been at the core of several legal battles. The National Resource Defense Council, NRDC, brought suit against the EPA because the standards did not provide a zero-risk level. In 1987, the D.C. Circuit Court ruled against the NRDC's zero-risk argument, but required the EPA to determine safe level of emissions, and the additional reductions were needed to ensure an ample margin of safety. The 1990 Clean Air Act amendments directed the EPA to set standards for all major sources. These standards require that a particular source category implement the maximum degree of emission reduction that the EPA determines to be achievable, which is known as the Maximum Achievable Control Technology, MACT, 40 CFR Part 63. The EPA published the initial list of source categories in 1992, and since that time has issued several revisions and updates to the list and promulgation schedule. Vinyl chloride was included on the initial list, and the EPA considered that the MACT standard provided the ample margin of safety required by the court decision on vinyl chloride sources. The EPA issued Part 63 MACT standards for the polyvinyl chloride source category in July 2002, based on the existing risk-based rule for vinyl chloride, 1976, to specially address emission concerns from PVC plants. A lawsuit was filed by Mossville Environmental Action Now, and the PVC MACT was vacated by the District of Columbia Circuit Court of Appeals in 2004. On April 15, 2011, the Environmental Protection Agency, EPA, proposed a rule to update emissions limits for air toxics from polyvinyl chloride production, PVC production. The rule proposed Maximum Achievable Control Technology, MACT standards for major and generally available control technology, GACT, for area sources of PVC production. Emissions sources addressed in the proposed rule include PVC process vents, stripped resin venting, equipment leaks, wastewater, emergency relief valves, and storage vessels. To determine the proposed emissions limits, EPA gathered information on PVC production through review of previously collected information, current literature, data from the National Emissions Inventory, and meetings and voluntary information submissions by industry and the industry trade associations. Also, the agency collected information from PVC production facilities using the authority under the Clean Air Act in the form of an electronic survey and requirements for emission testing of toxic air pollutants and toxic air pollutant surrogates, such as total hydrocarbons. The proposed rule would set emission limits and work practice standards for total organic air toxics, and also for 3 specific air toxics: vinyl chloride, chlorinated dibenzodioxins, and furans, CDDF, and hydrogen chloride. While a final rule for PVC was published in 2012, there is still a larger amount of controversy with the regulation. The EPA announced that it would reconsider its February 2012 final national emissions standards for hazardous air pollutants, NESHAP, affecting the industry. The 2012 revision expanded the number of specific pollutants the plants would need to control. The rule also established separate emissions reduction requirements for major and non-major sources of air pollutants. Neither the PVC facilities nor the environmental groups were satisfied with the 2012 action, and both petitioned the EPA to reconsider aspects of the action while simultaneously filing separate petitions for review with the D.C. Circuit. According to the industry petitioners, the EPA issued its revised NESHAP without proper consideration of key issues. They also contend that the EPA simply does not understand PVC facility operations, and that the agency does not trust facilities to accurately report their emissions. Meanwhile, the opposition contends that the regulatory actions are not enough to protect the public. Vinyl chloride emissions remain in public discussion. The Clean Water Act, 1972, created the National Pollutant Discharge Elimination System, NPDES permit program, which controls water pollution by regulating point sources that discharge pollutants into waters of the United States. Point sources are discrete conveyances, such as pipes or man-made ditches. Industrial, municipal, and other facilities must obtain permits if their discharges go directly to surface waters. In most cases, the NPDES permit program is administered by authorized states. Permit limits are based on technological control standards and are designed to protect overall water quality of the receiving water body. Additionally, most stormwater discharges are considered point sources and require coverage under an NPDES permit. The primary method to control stormwater discharges is the use of best management practices, BMPs. The discharge limit for vinyl chloride is 0. However, normally it is not an issue because of the high volatility of the compound. The Safe Drinking Water Act, 1974, requires the EPA to determine the level of contaminants in drinking water at which no adverse health effects are likely to occur. Contaminants are any physical, chemical, biological, or radiological substances or matter in water. Maximum contaminant level goals, MCLG, are non-enforceable health goals based solely on possible health risks and exposure over a lifetime. The MCLG for vinyl chloride is 0. This is not an enforceable level. However, the EPA requires that the amount of vinyl chloride in drinking water not exceed 0.002 milligrams per liter, mg/L of water, 0.002 ppm, which is the detection limit of vinyl chloride. There are concerns with vinyl chloride in groundwater. Possible sources to groundwater include landfill leachate, as well as spills of vinyl chloride or chlorinated precursor compounds. Under anaerobic conditions, biodegradation of chlorinated compounds can result in vinyl chloride production, particularly trichloroethylene, TCE. Vinyl chloride released to the soil does not absorb onto soil particles. Any that does not evaporate migrates readily to groundwater, where it can remain for months to years. Thus, vinyl chloride exposure from drinking water should be considered in areas where groundwater is contaminated with TCE. The Comprehensive Environmental Response, Compensation, and Liability Act of 1980, CERCLA, is a federal law primarily concerned with the cleanup of sites contaminated with hazardous substances. The regulation also has defined procedures for reporting emergency releases of hazardous material. Upon release of a material above its reportable quantity, the U.S. Coast Guard, state, and local officials must be notified within 1 hour. The reportable quantity for vinyl chloride is 1 pound. Vinyl chloride is on the list of chemicals in Emergency Planning and Community Right to Know Act of 1986. Section 313 of Title III of the Superfund Amendments and Reauthorization Act, SARA, requires owners and operators of certain facilities that manufacture, import, process, or otherwise use the chemicals on this list to report annually any release of those chemicals to any environmental media over a specified threshold level. The EPA used 1999 reported emissions data for all 50 states to model ambient air concentration and potential human exposure. Based on the estimated risk calculations, vinyl chloride was found to meet criterion of a regional cancer risk driver, meaning upper bound lifetime cancer risk exceeded 1 in a million to more than 1 million of the U.S. population. Employers have the primary responsibility for ensuring that their personnel are trained appropriately and that their activities are compliant. The individual employee is ultimately responsible for being knowledgeable about the hazardous materials they work with and complying with applicable regulations. This information is intended to supplement an employer's existing health and safety program and should not be used as a substitute for expert safety and medical advice. While vinyl chloride is dangerous when handled improperly, vinyl chloride operations need not be hazardous, providing the hazards are recognized and handling instructions are rigidly observed. Any person handling vinyl chloride should be sufficiently trained in the handling techniques, have specific first aid instructions, and equipment available for use in the event of personal contact or exposure.